want simple, not just easy. Now, if you do not know who this is, we are talking about a bit of a Zig core. What is it? He's one of the core maintainers of Zig. I know he does a lot. I know he does a lot of streaming. He does a lot of. We'll link all of his details down below. I know he's community manager of something, right? But I think he also contributes, does documentation, does all sorts of things. You've surely read plenty about how simple is good, but what's wrong with easy? Ooh, I love this take. Ooh, I love this. Simple to complex is the dimension that describes how irregular and interconnected a system is. Simple systems can be broken down into smaller pieces that are understandable in isolation. If you make changes to one of those pieces, you don't have to fear unexpected ramifications in parts that are not directly connected to what you're operating on. I see you've never programmed JavaScript. JavaScript. I love it. We don't use TypeScript around here. Complex systems are the exact opposite. You need to keep in mind a lot of things and tread carefully. Okay. Easy to hard. You know, I would actually make some argument that in some sense Rust can be complex by this definition, in the sense that how you design a singular component can have great impact on the rest of your system. And as you make changes to that, you do kind of have to outcrop all of it. You know what I mean? You do have to kind of go through and you'll have these large wave of impacts based on it. It's interesting. Rust drama, we will do Rust drama here in 1 second. No, you're not getting baited. The next article is the Rust drama. Easy to hard is a dimension of how much energy and time it takes to successfully execute something. Easy things generally require less preparation, can be done reliably even by inexperienced individuals. By definition, hard stuff requires more effort, and not everybody gets it right all the time. Okay, good. I like this. I kind of like that already. I like the idea of separating these two things as two different lines, right? I've always said simple is not easy. I love to see this. All right, it goes without saying that complex things tend to be hard, while simple things tend to be easy. But that's not always the case. Software engineering can shift this balance almost alchemically, although not always for the best. I can't say that word, okay? My tongue doesn't pronounce those symbols well. Building abstractions. Every time you build an abstraction, you encapsulate a given amount of complexity, making it easier to use. When you print to a terminal, you're probably doing it in a single line of code. That's an abstraction over a whole lot of subsystems you might not even know about. It's easier to print that way, but the complexity is still there, hidden behind a single function call. Love this definition. This is great. So what's the point of abstracting? While in the previous example, abstracting did not decrease the complexity, it did draw a box around a subsystem. If you remember, simple systems are made up of smaller boxes, so abstraction is a step towards composing bigger systems without increasing complexity too much. It's also good that it made things easier. If it took 100 lines of code to print something to a terminal, we would be years behind compared to where we are today just because of all the economic implications. Yeah, that's fair, especially as printf debuggers. Printf debuggers wouldn't even exist in this case. That's me. I'm that guy. This is why we don't write everything in assembly. It's easier, more economical to write in higher level languages, and function calls and for loops and other control flow structures prove to be good abstractions over machine level operations. That's right. Go-to statements with fancy names are fantastic. Change my mind. You're a printf. You're that guy too? You're not that guy, pal. You're not. I can tell right away with your VS Code open. I can see it with your gigabytes of RAM going on. You're not that guy. You're not a printf'er. Okay, I can tell right away. You walk into Starbucks holding the Phil's coffee. You're not that guy. You're just not that guy. Keep in mind, none of these things further simplifies assembly code, but they do actively prevent it from exploding in terms of complexity, as it would easily do without small boxes such as functions. You might as well kill yourself right now. Web development with assembly. Bob Johnson with his therapist. You know, one thing that's missing is whenever you make one of these box arts, make sure that you don't say O'Reilly. You got to go, oh, really. Like, oh, really is like that. It's just the key. This joke lost some of its punch in the wake of WebAssembly. There you go. Oh, really? You got to go with, oh, really. Not all abstraction manages complexity. This is a fact of life. This is why I say never abstract first. You got to know what the abstraction is before you do it. Abstraction is sometimes introduced just to make things easier. An example would be when you are introducing a new interface with the sole goal of making it easier to swap in and out a replacement for a component. It will take you less effort to make that specific change, fewer references to update, but the box you just drew is a second layer around a pre-existing block, the concrete class. Yes, this is a great way to put it. For example, about a database class and an iDatabase interface. That interface is only useful for swapping in a new database. If it were any way of abstracting what the class does, it would have had a different name to begin with. This is actually a really good point, which is something that I think about a lot, which is this right here. When do you interface something out? Typically, you interface something out because you want to change it. But how often do people interface something out without ever changing it? Right? Like it's a forever, I have this here because I want it here, and therefore it's there. Even for unit testing, a lot of times you do that, and you don't even unit test it, right? You don't even unit test the damn thing. You just simply abstract it out of pure habit. I've been doing this renaissance in my life where I actually am doing like no abstraction ever until I'm like upset at myself, right? And once I'm upset at what I've written, then I abstract on this one piece. And lately I've been finding that I've been writing better code, though the initial pass is more shitty. And it stays shittier longer. Like, I'm kind of embarrassed to show it to people. I'm like, ugh. But I find that I've been liking it a lot more, right? I've been writing bigger functions and just kind of like trying to find where things are at in a more exploratory way. That interface is only useful for swapping in a new database. If it were a way of abstracting what the class does, it would have had a different name to begin with. Easier is better than hard. All else being equal, there is no reason to prefer hard over easy. Stealing a quote from economics, the field of study, we have an infinite amount of things we could learn or build, and an ever limited amount of time and energy to do it. The cheaper we can do it for, the more we can have, and the benefits compound over time. It's a bit of a trivial statement, but I want to make it clear before diving into the real issues. So I'm not going to lie to you. I've been trying to learn OCaml, and I've also been using ChatGPT to really help me through it. ChatGPT led me very far astray this morning, just completely made up shit. And it took me a very long time to figure out that it was making stuff up, though sounding really correct. But I've really enjoyed the process overall of using the AIs to help me. I don't know. I have a new appreciation for it. At the same time, I'm very upset. GPT-4. I don't use that 3.5 bullshit. I go full GPT-4, okay? GPT-4 play. The rules of abstraction. As I mentioned before, introducing abstraction has two main effects. Lowers the difficulty by hiding some of the details, fewer lines to write, fewer things to keep in mind and think about, or even write to know, or even to write out know. Identifies a cohesive subsystem and draws a box around it. The box becomes then a tool that can be reused to build bigger systems while keeping complexity down. Okay, the second point, complexity management, is not trivial. It's easier to lower difficulty rather than to constrain complexity, and that's often what happens when web development is blind to this concept. Easy software that encapsulates more complexity than it should. Dude, this is such a unique statement. I can't tell you how often I will try to encapsulate something. Like, just say you're rendering some stuff, and then you encapsulate it, and it's really simple on the simple path, and it's really hard on the non-trivial path. GPT-4, $20 a month. Yeah, GPT-4. But really, I realize this happens constantly, where I think that's a good rule of thumb, that if you encapsulate something to make the easy path easy, you're doing it wrong. Easy complexity. Easy complexity shows up in many places, causing all kinds of problems. We even have a friendly name for this for some incarnations of easy complexity. Bloat. Saying something that is bloated is sometimes taken as a generic complaint against a misunderstood technology. And certainly the term gets abused, but it's nevertheless a legitimate way of describing something that falls into management complexity in a misguided effort to make things easy. Using bloated tools. The universal property of bloated tools is being resource hungry and needlessly slow. In the beginning, this seems almost innocuous, but as time goes on, you will find that some significant percentage of humans and system times get wasted on waiting for them to perform even trivial operations. When something breaks or behaves strangely, there is no way of knowing what exactly went wrong and why. Developers that over-rely on this type of tool get progressively caught in a form of lock-in where the tool removes them from the details of what they are doing. The tool does it for me, making them more productive, but at an unfair price. The lock-in is not just in terms of technology. When you only approximately know one way of doing things, you will also be limited in the range of things you can do, because every small deviation from the tool's sanctioned way will become a serious obstacle. This is such an amazing, this is an incredible statement. Christoph, I have a huge respect for you for even just like such properly wording this in such a way that I think makes a lot of sense. I really like this. I say this pretty frequently, but this is one of my reasons why I have a huge hesitation around this whole serverless movement is that these new people are jumping in. They have no idea how anything works at any level. They're using React, server components, doing all this, Tailwind. Like they have no clue of the actual foundation at all. And I'm not saying that's even a bad way to start. How much knowledge do you need of the foundation before you start? It's like a turtles argument, right? At what point do you stop turtling? But I also see the downsides, which is if you do that and you don't jump back out of it at some point, you have to keep on trying to bring your turtle level down every now and then. You know what I mean? Yeah, no foundation. Like every time you learn something, at some point you have to lie to yourself a little bit, right? To understand something fair, you need to lie to yourself some amount. Like last night when I was learning OCaml with modules that have functions that produce modules that take in modules, right? These functors, as you guys keep calling them. Like for me, it's like a log having a baby, like Leota says. And so it's like right now, I'm just lying to myself. It's just a thing that exists. I don't even know. Like I know all those words individually, but when you put them together, I don't know what it means, and I'm okay not knowing what it means. The self-preserving structure of these problems is nothing short of amazing. Maybe in the beginning, the developer tried to investigate root causes and indifferent ways of doing things, but failure after failure, it's reasonable of them, although ultimately wrong, to conclude that this approach is just a waste of time. At that point, some decide that the right solution is to double down on learning how to cope with the tool's quirks and intricacies, which will result in even more wasted time once a new shiny tool comes along. It's an interesting statement. I mean, these are all very interesting. Like, again, I'm going to go back to this OCaml. This morning I was writing a tool, a CLI tool, and I was using a Unix subprocess to launch, and it was like somehow my standard out was being redirected to just that subprocess, and I couldn't print anything. And I asked ChatGPT why it wasn't working, and ChatGPT gave me all these answers, and I kept trying them, and they were all uniformly wrong. And finally I just said, the thing's swallowing my output. How do I prevent Unix subprocesses from swallowing my output? And it was like, oh, like this. And I was like, the problem is I knew what was wrong to begin with, but I wanted to understand how AI do things. And it led me on like a half an hour path of trying thing after thing that was just wrong, which is very surprising because, like if you don't have that foundational knowledge, you wouldn't be able to look at it and just say, yeah, duh, it's right there. Like, I know what the problem is. Yeah, the link will be in the video for sure. I see everybody wants that so bad. File descriptor hell. Here's this one. It's Christoph.it, blog, simple, not just easy. All of the forces in play at software engineering, this is one of the strongest forms of natural selection. Choosing slow and unreliable tools will make you slow and unreliable developer with a limited and quickly deprecating skill set. It's harsh, I know, but true. Choosing better tools won't make you necessarily a good developer, but when you can understand what you're doing, troubleshoot problems, and in general be able to iterate quickly, then you'll have real opportunity for improvement. I love this. This is why I often say I don't care that you use VS Code, but just take time trying something else. Just go bare metal for a little bit. Or not even bare metal. Go NeoVim. Enjoy NeoVim for like a month. Why do people customize? What is the purpose of it? Why do they always say they feel faster afterwards? Well, because they change how they look at things. They rely on different tools. They rely on doing things differently. And then you can still take all of that back. You can take it all back to VS Code. But just the sheer act of doing something vastly different is incredible. I actually do want to use Ed for a day just to try it, just to like really jump in and try Ed for a day. I'm purposely avoiding naming names, but I'd like to give positive shout out to JavaScript. Okay, we all equate JS with bloat, but in my opinion, what happens there is mostly the natural result of a healthy ecosystem where many different, although sometimes half-baked abstractions compete against each other. This still has a negative effect of making it harder to make sense of things and causes some developers to experience burnout, but the number of broken developers, as per description above, that the JS ecosystem creates is not proportional to the perception of its bloatiness. Okay, I think the biggest number I think the biggest number of that type of developers comes from different ecosystems where bloat is the result of hostile design. Dude, is this like a shot at Rust? This is a shot at Rust, ain't that? You telling me that's not a direct shot at Rust? That is a shot at Rust for sure. In conclusion, using bloated tool chains will have negative effects, or C++, one of the two. Using bloated tool chains will have negative effects on both your productivity and personal growth. Slowness alone is a problem, but when combined with unreliability, it becomes devastating. Think about the next time you see somebody open their IDE and wait for it to load, make a change, and then have to wait before the red line underline causes their change to disappear, plus the occasional crash. The reliable environment is a fundamental prerequisite for building competence. The second most important prerequisite is feedback loop that allows you to quickly gauge the result of your actions. The tighter, dude, I swear this was a direct attack against Rust because I literally do this all the time. I open up NeoVim, I wait for the Rust thing to load, which takes like an hour, and then finally when it does load, I have to do :E to go LSP. The second most important prerequisite is feedback loop that allows you to quickly gauge the result of your actions. The tighter that feedback loop, the better. And when it takes a minute to build a project and run a fistful of tests, the loop is definitely not as tight as it should be. Using bloated frameworks will prevent you from understanding the details of what you're doing and cause your software to inherit bad traits such as slowness and unreliability, further spreading the effects of easy complexity. New approaches will inevitably come, and if you never built an appreciation for different trade-offs, all change will seem useless and arbitrary. The economic of complexity. If you search Word versus LaTeX in Google Images, you'll find a few pictures similar. Yeah, I like this. Effort and time consumption. This should probably be a lot higher, and then it should be like a straight line. I agree with this. I fully do agree with this take. This picture is trying to convey that Microsoft Word is easier to use than LaTeX, and the document size increases. You'll quickly get to a point where it actually becomes easier to use LaTeX, despite the inverse being true initially. Complexity makes things hard, and Microsoft Word fails at containing it, causing difficulty to skyrocket. This is why you can't ignore complexity. It does not matter how easy you try to make things. Complexity is almost radioactive source of difficulty. In terms of value over time, if your daily job involves working on big and complex documents, learning LaTeX is going to pay off immensely compared to sticking with Word. More importantly, learning the idea of giving semantic structure to documents is going to pay off more than learning that one arcane procedure required to drag and drop pictures without messing up the layout in Word. Once you begin appreciating the relationship between structure and semantic meaning, you won't feel bad when something new comes along and starts replacing LaTeX, because the fundamental principles will transfer to the new tool, while the image replacement incantation for Word is probably going to stop working in the subsequent release, leaving you with nothing. I leave it. Where did Microsoft Word hurt you? In the images. Image layout hurt me very bad. Dude, I actually fully agree with that. Every single time I have to put a stupid image in that program, I swear it is the worst experience in the universe. I leave it for you to decide if and how that picture translates into tool chains, frameworks, and even software you write yourself. But there is an old saying that I think is still as valid as ever. I don't remember the precise quote, but it is something along the lines of, the value of a maker is reflected in the quality of their tools. Thanks for reading my first blog post. That is a great first blog post. I love everything you had to say here. I think this is great. Go check out the links. I will link this blog post. Go check out the links. Go give them the follows and all those kind of things. And for those that are live today, here you go right now. Doesn't make Zig any better. Oh, wow, that was quality. I want to read it again. It was actually really good. I thought it was really genuinely good. I'm not sure I agree with the last quote. I'm not sure if I do or don't agree with it, but I like the notion, right? The notion, okay, how I read this thing is that there's two axes here. There's the strive for quality and the strive for time. And they do kind of cross each other, right? In the sense that you kind of have to pick which side you want to be on, because you can make things more and more quality, or you can make things, faster and faster. And you kind of have to decide which one you wish to go with. Another thing is that there's this idea that if you make a tool small enough, you don't have to make a lot of those trade-offs. You know what I mean? The quote is from The Witcher. Interesting. The Prime line, I agree with the statement. It was indeed his first blog post. Give me back my son! You know what I mean? The name is we're about to do Rust drama, and you're missing the moment. Rust has done up again. The greatest engineers of all time, a gen.